Welcome, everyone. Thanks for joining us for today's event. My name is Ayi, and I'm the community manager for RLadies Lagos. And I'm gonna be hosting this event with Mona Vlad, the community leader for RLadies Paris. Together, we're bringing this event to you, courtesy Our Ladies Without Borders. So the idea of Our Ladies Without Borders is to bring Our Ladies group together globally to co-host events. And when we all know that we could do a lot with having other communities join together to co-host events where we assist each other and make things easier. We share the burdens of hosting an event because we understand that it's not always easy. So yeah, shout out to Our Ladies Paris and Our Ladies Lagos for making this happen. And thanks to Emmy for accepting to speak here. So we are very excited to have all of you on the call. So as we commence this event, I would like to do a little shout out to our sponsors, Common Room, Beauty Odyssey, and Microsoft Teams. So this platform has been supported by these three fantastic people, and the other platform you're also bringing this to is CMX community in Lagos, which helps community members thrive. So if you're a community manager, this is a perfect community to also join because you see best practices. Everyone in this community also has the communities they manage. So we help each other, we connect with events and all of those things. So without further ado, I'm going to be passing it over to Munat, Muna, to take it away.
Yeah, thank you. Hello everyone. Thank you again for joining us. I'm so excited to collaborate. You are so excited to collaborate with iLadies Lagos in organizing this meetup, and we will have some other meetups in the future also together. Also, you are so honored to be hosting Amy Tanaka. Dr. Amy Tanaka is a senior lecturer in statistics at Monash University, Australia, where she teaches various statistical units, including R package developer. So I'm sure we will be learning a lot from her today. Thank you again, and the screen is yours, Amy.
Okay, I'll start with sharing my screen. Now, it is the first time I'm using this platform, so if something is not working for you, please just let shout out and let me know about it, or either put it in the chat. Okay, so I should be sharing screen now, and hopefully you see that. Now, is that font large enough for everybody to see?
Yes, you are seeing the R session.
Yep. And the people okay with font size?
Yes, they confirmed that.
Okay, excellent. So it is an interactive session. So feel free to chat and talk to me as you go along. And also this whole notes that I'm writing up, it is going to be available on the link. So don't worry about the fact that you need to write down notes. It will be available for you. So hi everybody. So I am a senior lecturer, as Mona introduced me at Monash University, but actually I'm in transition. So I'm about to join Australian National University from July onwards. So before I actually start talking about our package development, what I wanted to actually ask you are some of your favorite R packages, if you don't mind either listing it on your chat. And I don't know if you have a functionality to shout out, but if you have that, please do so as well. Tidyverse. ggplot, yep, I've got that too. Anyone else? dplyr, yeah, and that's part of tidyverse, isn't it? Once you load it up, you actually get ggplot2 and dplyr together. Plotly, I like that as well. What else do people use? Shiny, Narnia. I don't think I have that installed actually. It doesn't come up. This is my new computer, so per. Okay, so there's a few of them, and a lot of them are tidyverse packages, isn't it? Which really tells you how popular they are. Now, before I talk about R package development, though, what is an R package? Well, at the very basic core, it's just a container, and basically just a handy way of like distributing a set of functions, or in some cases, like R packages can be for sharing data. You might have a Shiny app, and therefore you might want to have a convenient wrapper to launch the app. It could be that you might have an R Markdown template and you want to be able to distribute that template easily. So it's just a container which actually shares a lot of things around, mainly to do with R functions, but it also has some other functionalities. Well, before you even start really developing R packages, I think one thing you really need to kind of have a clear idea is to actually map out what the motivation for the package is. It's so like easy to think, oh, we want to make an R package, but there's no point making an R package for the sake of it. You do need some kind of goal behind it. So first thing you do really with R package development is really brainstorming. Like, what is your package supposed to be doing? Who is it meant for? Why would we want to use it? Like, why not use some existing R package before developing it? If there is some that's already got a similar functions in there. And then also, if you were to make it, how are you going to kind of distribute it? So these are kind of things that you want to map out and think about it even before you do any kind of like coding. Now, of course, when it comes to R package development, probably best to show a demonstration. And so as an idea, I just thought that maybe today what I'm going to do is make a demonstration of making an R package that does some kind of simple matrix operation. So it's not a very serious package, and it's going to be kind of simplistic in its operation, because we don't want to get into crux of like what the actual operation of the package is, but more how to develop around it. So let's say we have a matrix, right? And hopefully you all know what a matrix is. If you don't know, it's just an array of numbers that are laid out with like rows and columns. So this is a 2x2 matrix, and I've got like 4 different entries, 1, 2, 3, 4, as you see there. And before I start making our package, I might think about the interface, because essentially what I want to do is I want to kind of think about how people can use it, or even for myself as a user, how would I try to lay it out so that it all works together. So what I have done here is to just kind of think about what the functions might look like. I've already got my goal that this is some kind of matrix operations, and they are supposed to be pipeable functions. And I think a lot of you might be quite familiar, if you already know tidyverse, about piping, which is a very handy way of actually doing things where you're putting things in like sequence, right? Certain operations in sequence. So in here, what I'm doing is that I've got a matrix. And so if you could put this in R, you can see it's just a 2x2 matrix, which was the one that's written up here. And what I'm doing is like for each like operation, each line of the code, what happens is that I'm trying to modify what's happening in this matrix. So like this second line, I'm just saying for entry that's in row 1, column 1, I'm going to add 2 to that. And then in this third one, I'm going to say, okay, on entry second row, second column here, which is currently 4, I'm going to subtract 3. Then this one, I'm going to multiply after that's all done, this time by multiplying 4 for the entry number row 1, column 2. So this one. And then last one divided by. So basically, it's kind of like applying these operations in a sequence. So I kind of, settle in and say, okay, this is going to be what I'm going to put into my package. And it's going to have this layout, and these are the names of the function. And here I spend a lot of time, usually when I try to develop R packages that are meant for other people, to have some kind of way that is consistent in terms of the way that the user interface is designed. So this one is all to do with entry manipulation. So I thought I'll prefix it with entry. So you kind of know as a user, like, okay, they know that they are manipulating something to do with entry. And then the second word is something to do with the actual operation that you're using. Now, the other entry here is that because it's a piping function, the first entry is always going to be a matrix. The second one is got this another function I'm going to create, which is going to signify the entry. And then the last part is actually whatever modification I'm doing. So applying certain things that's specified by the function itself. So this is like sort of like my idea of a package. And I'm going to demonstrate how I'm going to implement this. So first, of course, you need a set of functions before you can really, have an R package. And they might have these functions already. They might not be packaged up, but they might exist. And this might be the case for you as well, right? Sometimes, when you're doing your analytical work or maybe some other work, you start to pile up these functions, and then you come to a point and go, this will be handy to have it as a R package instead of having to source it each time or copy and paste the function each time. So maybe that's what happened. I ended up having all these functions, very simplistic again, but so, this is entry add. First entry is always matrix. Second one is like an entry, which tells me the row and the column. And the last one is whatever modification I'm doing. And you can see here that I'm modifying the matrix. So when it's an add, I'm adding onto a particular entry that's been given. If it's a subtract, it's subtract. Multiply by is multiply. Divide, divide. E function is quite just simple. It does just returns like a vector of size 2, which I is supposed to be row, J is supposed to be column. And it has this kind of like simple check in between them. So those are the functions that I might already have from the beginning, right? And then next thing is that I go, okay, now I think I have enough meat to actually put it in a package, and it'd be much more handier to call up a package rather than copy and paste this each time. So now this is where I'm going to showcase and do some demonstrations, probably make mistakes as well. So, you can have fun also watching me fix up my mistakes as I go along. So the R package development, the modern way of doing it, really relies on the first two package, and it's handy to use ROX engine too for documentation purposes, and then test that for unit testing and package down for really having a package website. So the three latter ones are kind of optional. Maybe the third one's quite useful, so maybe not so optional, but it's very useful in the workflow. The last two, whether you have a website or not, is optional. Test that, depends on how rigorous you want your package to be. And generally good practice. Now, these are the 5 packages I would recommend you use in order to help your R package development. And compared to the past, it's actually, thanks to this, it's actually made it much easier to do package development. So after this, you should give it a try. And you probably, if you already have a set of functions, you probably can make a package in like 10 minutes. Okay, let's get started. More about the R package description. So if you don't know what R package constitutes, what happens is that at the very minimum, you need these 2 files plus an R directory that contains R files. So this is a minimum requirement to be an installable R package. Now, description is going to have like a metadata for the R package, and you will have your package name, titles, description, and I see a typo. So title and description. And who the author is, dependency, licensing, version number, bug report locations, and so forth. So that's kind of useful like later on when you actually need the meta information of the package. You can usually find it in the description file. The R directory is going to have a set of R files, which is going to contain your functions. And this is where mainly you will do a lot of the writing. Namespace is something that you don't generally need to manually create this. In the past, you had to do this manually, but thanks to the current modern workflow, these are automatically created so long as you follow the actual workflow. You may have other things. For example, you may have a data directory that contains a binary data. You may have data-row, which is going to contain raw data. And this one doesn't get bundled up, but usually whatever you have here is to actually generate the binary data. You may have other inst folder, and that's like if you have additional arbitrary files that you needed to be installed in your package, you put it in here. And an example of that might be like a R Markdown template or something, or even like Shiny apps that you want to launch. The Shiny app will go inside here. But these are optional, and you don't need them. The minimum is really these three things that you see over here. Now, let's try creating this R package, and we're going to use this package. Now, with this, what happens is that you can call on use this, and then I'm going to do create package, and then you can put in the name or the pathway as well as the name of your package itself. Now, before I do that, actually, because the naming of a package actually is a tricky thing, and you don't want to kind of overlap with any existing packages. So I recommend using the available package to check if your package name is taken. So you can do this and run it, and then it will tell you whether it's available or not. And I'll put that in the code as well, so you can see. Let's check if package name available. And you can see this package is valid and it's available. So nobody's used it in CRAN, Bioconductor, or GitHub. So which means that if I want to make this a serious package, at least I have a means of actually distributing it and without having a clash with an existing package. So that's good. Now let's do the use this, now that I know that I can use this one. And I'm going to go and create this in my documents folder. So when you call this use this create package function will actually create like some of the minimum anatomy that's required for an R package into the location that you specify. So when I call this, it's gonna create and launch another RStudio instance, and it's launched in another section. So I'll just have to open it up here, and you can actually see here now in the documents folder, I've got the matrix ops folder, and then you can see there's like the R file, the namespace, and the description. These are really the three minimum that's required. And it does create an R project as well. So if you double click on this, it will launch easily into your RStudio IDE. Now, here I can start entering things. And before I do that, I do recommend that you use RStudio IDE in order to do the development, because there's actually a number of things that's well developed for package development in this framework, including the build tab over here. So while you can use other like IDEs, this one is probably the most easiest when it comes to development of our packages. Okay, so now I want to enter my R functions. So to do this, I'm gonna go use R, And then I will have my matrix, well, I'll call it maybe entries. So this is where my functions for doing the matrix manipulation is going to go. And when I call this is actually a simple function. All it does is that it's going to create a new file inside the R directory, exactly the name you specified. And then here it opens it up for you automatically when you're in the RStudio IDE. It's not something that like you need, absolutely, but it just makes the whole development much faster. So every time I need to make a new R file, I just call use R, and then basically it will create that file for you. Now it doesn't create the function for you, so essentially I do have to copy and paste what I created before. Let's take that and put it here. Okay, so kind of getting there, like in terms of the fact that I have now a package and it should work because it's got all the minimum required parts, and now I have function. Now, in order to check it's working, well, first of all, what you want to do is to actually load this up and check how it's doing. And while it might be a little bit tempting to, copy, paste this and check it out in the actual console like this, what you want to do is to kind of like use a fast way of doing things. And that's where DevTools, the load all comes in handy. When you do this, what happens is that all the functions that are contained in the R directory gets loaded up into your local environment. So if I do that, it's loading, and then now I've got the function like entry add and so forth all in there. So all good in that sense that if you want to interactively test, this actually works by doing that, by doing load all. But of course, like, typing also takes time. And again, in the development, one of the key things is to be fast. And so if you want to do it really fast, one thing you can do is to actually use a keyboard shortcut. Now, in this case, if you want to do the load all, what you can do if you've got a Mac is to use Command-Shift-L. And then that actually will link to the actual shortcut, which is to call the load all function within DevTools. Now, if you got Windows or Linux, your keyboard will be Control-Shift-L. And then that will also do the same thing as here, where instead of having to type each time, you can actually load as many times as you need. And that's a key part about development, where you need that rapidness. And so you want to master the shortcut for that purpose. Now, if you want to know like all the shortcuts, there is actually like a help file. If you go to help, and then if you got RStudio IDE, and then go to keyboard shortcuts help, and then this will tell you all the shortcuts that's available. And you can see under the build, this actually has all the shortcuts that's available for building purposes. And you can see the load all part here. Now, I use load all a lot because I tend to interactively check whether things are working or not. And in this instance, what I might do is, for example, maybe I'll assign matrix 1 to 4 and y equals to 2 and call. So I'm going to make that matrix I showed you before. And so that's a matrix. And if I want to check if it's working, I might go entry add. And then on entry 1, 1, I might add a 4 to it. And you can see it's working, right? I can also do for other ones, if I do entry subtract, and then so this is subtract 4 from the first entry, and I do see that happening. So, it's easy to like interactively check this, and if I make a mistake, so suppose this one was 2 times x, and then I do that. And obviously that's wrong. That's not my intention for this particular function. But if I do that, notice here, it's added 8 to this one because it's adding 2 times 4 there. So it's fast. And then when you need to fix it up, fix it, load, check, and done. So that's part of the workflow process that I do quite often. But this is actually doing checks implicitly, right? You've created like a matrix, and then like, you kind of interactively checking it. But what you want to do is to actually, when you are creating something serious, is to actually formalize your tests. And actually, that is probably better than actually having to, make up tests on the fly. So I'm going to start creating tests. And for that, again, I'm using the use this package, and there's a use test function there. Again, this function really does something very simple. And all it does is that it creates a testing file for you. Very simple, but it makes the friction much less, because then I don't have to create the appropriate folders, and then I don't have to create the file in the correct location as well. It does it all for you. So when I do this use test, I just need to be making sure that I've got the file which I want to do the testing on open. So make sure that's the active one, and click this, and you can see what it does. It's created that test folder, test that, and inside there's a file called test-entries, which is going to contain the testings that are unit testings that's associated with this particular file. Now here, in order to see if it works, so maybe entry functions work, I'm going to use like test that functions. So I'm going to go expect equal. So let's say that I've got the matrix as before. I'm going to copy paste what I had before. So let's do that. And then to formalize what I did before, I basically did, what is it? I did entry add M, and then on entry 1, I added 4, which this actually should equal to a matrix. And that should be a matrix with 5, 2, 3, 4. And then 2, 2 by row. So this is actually what I expect it to be, right? When I do this operation. So I expected the first entry to be added by 4, and this is a matrix that I want. So it should pass this test each time. So here, now if I make like modifications, I can check to see if it passed the test. And you can see here that it's passed okay. But if I made a change as before, so make the wrong change. So this is not doing the thing I want. And if I run the test now, see how it fails. So I can then be assured that as I modify, like things are going to likely to, like there's going to be some checks in the process to make sure the function is doing what I expect it to do. So here, as I do the test, you can see the test is happening in this particular part. Now, this is actually doing a test for all the functions. The other one that's handy to know is that there is a test active file, and then this one will test only the one that's open at the moment. So this actually is useful when your package becomes quite big and you have many R files. So this one here, you can see, just test this particular one, and then I've only got one test and it passed. So good. Now here, before, what I was doing is that it was running here. You could click on the test tab here, but again, keyboard shortcut is a good thing to master if you want to be fast. So for the testing purposes, the shortcut is Command or Control if you're Windows or Linux, Shift T, and then that'll do the testing quickly for you. So I can do that for like all the functions. So then I'll have like a series of tests. So if it's a subtract, entry subtract, what should the actual result be? Well, this is supposed to be subtracting 1 minus 4, so that should be minus 3. Oops. Now it passes 2. So I'll just do that for the other two functions as well. Entry multiply by, and then that will be 4. Entry divide by, and then that will be a quarter. Oops, keep on pushing the wrong thing. Oh, I failed. Where did I fail? Entry function works. Object M not found. Oh, notice I have a mistake. This is the X and this is the M. And there you go. What else do I have? It's wrong. I did not do this on purpose. Entry by M, object M not found. What am I? Line 11. Is it line 11 here? Oh, yes, that's X. Oh, thank you. That's a bit silly. There you go, pass all, which means I have a mistake in my while here. There you go. Did not correct that. You can tell it was named X before. Well, thanks for your help. And see that I have like this help to correct that mistake very easily. Okay. Now, so far, how are you finding it? Any questions or? So there's a question, do we have GitHub for this? I will provide the link for all the R script, and I'll probably show you how to push this on GitHub. So the package will also be available on GitHub later.
You have also a question from Pierre. When programming with the tidyverse, how do you debug a pipe?
Pipe itself, you don't really need to debug, partly because of the fact that that's already existing in another package. So in that sense, what happens is that you can assume that the developer of that package has done their debugging. And that's a good entry to how to make sure that your package can use the pipe itself. Now, if you use tidyverse, you probably know that pretty much most of the tidyverse packages use what's called the Magritte R pipe, which is this particular one. So this pipe. There is now a native pipe as well, but which is given by this. And this itself is actually only available for when you got R greater than 4.1. And not everybody has that. So you may want to still use Magritte R. Now, Magritte R is a package. And then if you don't know what it is, the most usage that people have of this is actually the pipe function that exists within it. And if you want to use pipe within your package, and you don't want people to have to call Magritte R each time, what you can do is to make this as part of the dependency in your package. Now, because this is so common, again, it's one of those things that if you think that this is an action that requires a lot of repetition, generally speaking, the use this package has this. So if you go use this, and then there's a use pipe function, if I call this within the R development framework, what it does is that it's going to create a R file. And in here, if you look at your R, there's a file that's been created called utils-pipe. And what it does is that it imports the Margarita R pipe into there. So just by having this, and it's just written everything for you automatically, your package now allows you to actually use pipe within it. So if you have a look, at the moment, if I try to use pipe, it doesn't work because it doesn't know what it is. But now that I have installed or added the pipe in here, now what I can do, I don't think let's see if this works. I think I might need to do the documentation first, but let's see. I need to document and then load, then the pipe now. Oh. Or is it because I need to actually have a function? Yeah, so that works. Oh, maybe before it was just not there. I mean, I can try to restart just so you can see the difference. Let me delete that, so just so that you can see. So I'll delete the pipe and I'll restart. So I'm back to a state where the package itself doesn't actually have any piping functions. So if I try to do that, should terminate, because restart sometimes loads up the old one. Okay, so now it doesn't have any pipe. So if I try to use pipe on this, where does it work? Oh, it's in the document. Yeah, so that's the thing. I need to actually delete this as well. Yep. I forget. There's a whole lot of things that it does. Now let me try. The 3 pipe and then plus 2. There's still somewhere that it does exist. Wonder why. I deleted it. It's like a ghost. Okay. Does that exist? It shouldn't exist. Let's see. Well, that's really scary. I don't know why. Because I've deleted the pipe from my whole thing. But somehow the pipe works. I don't know why. Because I've deleted all instance of it. Okay, that's a bit of a mystery for me. I don't think I can solve it now, so I'll pretend that the pipe is there and it's all good. Now it's like a ghost where you do have like a pipe in the function for some reason, even though I deleted it. So I'm just gonna restore it. So here now again, the pipe should actually work within the package by having this part in there. Now, in order to do this, of course, you can actually see there's actually a certain tag that's happening. This particular tag here is actually what's called the R oxygen tag. So this is actually used by the R oxygen 2 package, and you wouldn't actually call this package on its own because its functionality is actually to basically look through your R files and find these special tags, which actually is going to be generating a certain special files within the R package. That what that means is that in general, you have a particular structure to this. And what happens is that there's a document function within DevTools. And what this document function does is to actually scan through your R files and find these special tags around it. It will process these tags. And once it processes it actually puts it inside the man folder. So let me run it, and you can see how in the man folder, it's going to process this particular file, and then you create a new one in there. You go, you got the pipe one. Now, this one you don't touch. This was automatically generated by our Oxygen 2. And when you actually load up your function and look at the help file, so if I look at the help file for this, see how this is coming from the matrix ops package, which is the one that I'm creating at the moment. And you can see how it's got the, the title, the description, the usage, arguments, and so forth. All this is actually read from the man, the RD file that's contained in the man folder. Now, in the past, you had to do this manually. And so if you used to work on our package development like 10 years ago, this was the norm. But the modern day way of really doing our package development is to actually write it out in our Oxygen tag and always generate it using our Oxygen. So now I don't have any documentation for any of the functions that I've created. And so here, what happens is that I'm going to start creating documentation for each one of these. Now, this tag for our Oxygen is basically you start with a hash and then this colon. And then here in the first one, you can add a tag title, but then optionally you don't have to. It's quite smart enough to know that the first line that you write is actually a title. So maybe I'll write matrix operations. And then you can write description. So short description. These are this adds a value to a particular entry of a matrix. Again, you don't have to actually put this art description. The line after the title, it automatically knows that it's actually a title. Just because this is very common, this often is actually omitted. So I can omit this, and then this one, it knows that it's a title, and it knows that this is a description, just by the ordering of what the tag, the Oxygen tags are. So if you want to be thorough and make sure that you know what it is, you can put those tags if you want. But the reason that sometimes you see these tags missing is that there is actually just a common usage, and therefore people often omit it. Now, the one that you really need to add is @param. And notice how like all the Oxygen tags actually show up, which is very handy when you're using RStudio IDE because it's meant for development. So it actually knows the existence of the Oxygen 2 tags. So in @param, this is where you start documenting what the argument of a function is. So the very first one is M, and then here I will say it's a matrix. And then @param, the next one was the entry. So entry, which is a vector of size 2. And then I've got X, which is the value to add. So I've got these documentation now for that particular one. But then here what happens is that in the final part, I'm going to add this export. This export tag tells me that this is going to be a user-facing function. And so when I run document, and then the shortcut for the keyboard is Command-Shift-D. And you can see it's doing the document. And then now I've got this RD added there. as you can see. Now I can also have a look at the current temporary one. And so when I open up the documentation, you can see again for my matrix ops package, I've got this particular RD file, the R documentation file created. Questions? How easy is it to copy and change some code in existing packages or combine parts of packages together if you're constantly using the same function for multiple packages? If you are using functions from other packages, what happens is that you would want to put it as an import. So that's where exactly the pipe function is what we're doing with pipe function. This one, I did not create the pipe function myself, but I'm leveraging off an well-used existing package, which has its own testing framework. And you can trust it because this is actually also maintained by the RStudio team. So when you use another existing one, you can import it. And you can see there's a tag that says import from Magritta, and you're importing the pipe function. Now, when you do import, you do have to remember to actually add this onto the description file, and there will be an imports and saying that that's a package, that's a dependency within a package. You need this to be installed in order to actually use some of the operations within your package. Again, if there's another package that you want to, another function that you want to use in another package, what you want to do is to, instead of copying and pasting it over, you may just want to put it as imports. If it's only like a small part of a big package, this depends on the license of the package. If it actually is got a permissive license, you can copy and paste it, and probably best to acknowledge it as well, again, depending on the license. But also, if you are using most of the functions in a package, it's probably a better way to do is to actually just import it. And that way you don't actually have to test that particular function as well, because the responsibility will largely sit on the actual original creator. So if there's an update to that function because there was some kind of bug, you will also actually benefit from that. But because it will, all the imports will be also, if you have the latest one, carry that latest bug-free function. Here. So do you need to be in a development session for the tags to show up? Yes, I believe so. So there is a part of the build tools. So there's a project, this particular project, they know it's a package. There's other kind of different project tools. And because this one, it knows it's a package, it automatically, I think, detects it. If it is not part of it, it may not detect it. But you can easily come to the project options, build tools, and then just select the package part there. When you use this function to create package, and this automatically launches, it does do that little fill for you. It actually completes many little small things that you need. So like some of the small things you don't even realize. For example, it actually made a .git ignore file for me automatically. It also made .rbuild ignore file for me automatically as well. So like there's small little things that use this package does in order to make the whole thing easier for you. So another question was about the suggests. So here we've got suggests, we've got imports, and there's actually another type of dependency in our package, which is called depends. Now, imports means that generally speaking, you probably want to use a function within there, but it may not be like it's some of them basically are not like a requirement for the package to run. If you need actually like a dependency, like a total dependency on all the functionality within the package you're importing, you go one level higher and you use a depends. Normally, you don't need to. Import is the main one that you probably want to use. And suggest is one step lower, which says that that particular package is like not necessary for the actual like most part of your R package to run. And you can see in this one that it's actually calling on teststat. And part of the reason is that teststat is actually used for the unit testing, but it's not needed for running the actual R functions within there. So suggests come up when like it's something that you need for parts of running some of the framework for development, but like essentially it's not a hard requirement. Another one that comes up if you actually make a vignette using R Markdown is that nita will come up here as part of the suggest as well. So there's like 3 different levels. And the ordering of this actually should not matter. So I can put imports just so that it's a bit nicer. Imports, suggests, and then the one that's one up higher is depends. Depends actually will load up all the functions within that package that you're depending on. So it's not recommended, and it's only for special cases. For example, if you are making a ggplot2 extension package, then you do need your ggplot2 package, right? Because it's an extension package. Then in that case, ggplot2 is a dependency. So it depends. But most of the time, it will be imports. So if you have to make a decision, generally speaking, put it under the imports part. Again, this is for when you're using functions from other R packages. Okay. Okay. So let me go back. Now, entry add essentially makes here, what I did was to export this. So this is now a user-facing package, right? So what it means by user-facing is that now if I install this package, and then now I try to call on the function, so entry add is there, and then I can kind of start using it. But if I do entry subtract, it doesn't actually come out. And then that's because this is actually considered an internal function. It's not a user-facing function. So I can use this particular function within the package, but I'm not using it so that the users can actually use it. So this is a case where if you got a package and you are calling in the function by putting the name of the package and then using : and then like calling on the function like this, if you ever seen this approach, what happens is that it's a difference between having 2 colons and 3 colons. 2 colon is for user-facing exported functions. 3 colons is for functions that are basically internal, more hidden functions. Yes, you do need to have @export for all the functions that you are going to have it as a user-facing. So naturally, this one was supposed to be @export as well because it was meant for user-facing. And so I put all this in there. And now once I do this, I do have to do documentation first because at the moment there is no man file for those. So when I do this, I've got it. It doesn't actually create a file, but it's exported in the namespace. So if I go to namespace, you can see that there's an export and then it's an exported one for each one of them. Now, namespace is also one of the requirements for our package, and you should not be editing this by hand. It's automatically generated. Okay, so in this one, what happens is that I didn't provide any title, and therefore what happens is that there is no RD file that's created, so no documentation is available. So when I call in entry subtract, like I probably need to load first. You can see there's nothing that comes up. And that's partly because there's no RD files associated with that. Now, because this is actually quite like a part of the same kind of family, what happens is that you might just actually put this within the same kind of RD document. So what I might actually do as optional is to have this like what do you call it, overall one. So I'm gonna create this now, and then this one I'll name it, and I'll call this matrix ops. And then instead, so I put null there so that it knows the cutoff there. And so this is actually just gonna create an RD file called matrix ops. So you see how it's created a RD file there. But I want all of these particular functions to be part of this. So here you can go RD name and then make it matrix ops. So they're all kind of going to collectively belong to this particular documentation. So I do that for each one of them. And last one, not that one, because that's not the entry. Okay. So now when I actually look at the documentation, entry add, see it's named on the matrix ops, and you can actually see each one of the functions collectively in there. Now you can also add examples. So you can do add examples. And then here, what I might do is just to go matrix 3, 2, add entry E1, 1. Let's add 3 to it. And then you can see there's an example part. Oh, you can run examples. That looks new. Okay, didn't work. I don't know. This is actually quite interesting. I haven't seen before. But anyway, you can see here that the example has been added there automatically. How easy is it to add the capability to run example code in the documentation? So you can see these code are something that you can add and it will show up. Now, in order to run it, normally you copy and paste and put it in the console. Later on, I'll show you the package down, which then actually shows you the output out of all this. So I'll leave this example later and we'll come back to it when we get the website version as well. Okay. So that's the main crux of it. Again, like you've probably seen like the repeat of things that I'm doing. So Control or Command, Shift L, load. This loads and you can quickly work it out interactively to see if the function is working. But then once you are ready to actually formalize it, what happens is that you want to make a unit test. And then so run the test to see if, like, when you make modification, is it still working? Control Shift test. Yep, passes. So very good. And then every now and then, if you change up the documentation, you got to make sure that you do actually run it so the tags actually create a man file and it updates the namespace. Command Shift D, and you get that. So this is like a common operation, and you just repeat this again and again and again, essentially to develop your R package. Oh, so I covered basically a part of this. And then the keyboard shortcuts. Now, the next part I'll share about how to basically share and collaborate on your package. But before I do, just want to stop to make sure there's any kind of clarifications or questions people have. Okay. So Alvis has a nice tip that you can actually use the example function in the utils to run the examples in the documentation. I didn't know that, so that's pretty handy. Okay. Now, when it comes to sharing, first of all, it's very common to use Git to do the version control. And I would highly recommend that you actually do version control because there's going to be a lot of changes. And also later on, if people want to use your package, it's a good idea to know which particular version they were using for reproducibility. And then if you want to make your package public so that other people can use it and also collaborate, I highly recommend also using GitHub. Pretty much like some of the recent Stack Overflow surveys suggest that like about, I think it's about 80 to 90% of people would actually use GitHub for like doing the hosting. And so it's definitely one of the most popular platforms of sharing your version controlled Git version controlled projects. The other ones that are also used are like things like GitLab and Bitbucket. They're much less though, so less than 10% of people use that. But that's also a valid way of hosting as well. My preference is to use GitHub, so I'm gonna use GitHub for this. Now, first instance is that you've got to initialize it with using Git. And then so when you do the use this function, call it use Git, it will talk about wanting to actually do that. And I put it in the wrong place because this is not my R package. It's here. And so you can see here that it's trying to commit. And so here I am just going to say yes to it. And then it's going to restart. And the reason it's restarting is that it's going to launch it and it's going to have a Git tab up here. I'm going to say yes, and you see launch, and it's got a Git part here now. Once it's got that, next part is I'm going to use GitHub. So there's a use GitHub there. And here, like it knows that it's connected to my account, so it knows to go for my one. But maybe if you're using a different organization, you can put your organization name here. But in my one, it will go to my one by default, which is Emi Tanaka. You can put it to private if you like. So this is actually false as a default, but I'm going to make it public. So I'll make that user default. So you can put this out if you need the options to be changed, but I'm just going to use a default because essentially it's already set up in a way that it works. And if you got your Git set up as well, this should be sufficient as well. So when I call this, what happens is that it's going to look at the name of your project, and it's going to create a repo with the same name as your project, which in general should be the same as the name of your R package. So launch this. It's creating the GitHub repository. Yep. And then do you want to commit? Yep, sure. And it creates things necessary. And then it launches in here, as you can see, my R package onto GitHub. So very handy because I'm just running just 2 commands and everything is all done and set up for you. Now people can actually install, and it's probably handy to have that instruction in a README file. So I will probably go back. Where have I put my function? Go. So I'm going to go back, and again, I'm going to use this package, and I'm going to create a README document. So when I call this, it's creating a README R Markdown. And then here, what I can do is start writing things up to complete this. So in particular, it'll be important that people know how to install. And then you can see that it's got a partial completion of that part already. I'm going to just delete the example part because they can fill out later. Yes, to demonstrate how to develop an R package. So you can have like simple write-up of here, knitted, And then once you've knitted, you can commit. So add readme push, and then now it should actually show this on your GitHub. So refresh and see how it's got the README. So now people know how to install your R package that's hosted on GitHub. So if you got GitLab or a Bitbucket, you can just replace that part with a corresponding host. Now, other things you probably want to do if you have GitHub is to actually create like a website associated with it. And this is actually really, really easy to do if you have package down. Now, if I run package down locally, the package down, and then, no, actually, I do use this, and I'll use package down. Again, very handy, right? Was use this. When I do this, it creates like the necessary files. In particular, is this YAML here, which just has very basics of like what the template of the package down website is. And then to see it locally, you can build site. And what this does is that it will scan through your documentation, and then it creates everything automatically for you, as you see here. So this homepage that you see is essentially from your README file. If you go to references, this is all the documentation you added. It reads your RD files, processes, and put in a way that essentially it's ready for HTML. So everything you see here was something that you saw in the help file. And you can see here an example. It actually runs it, but it says here that it could not find this particular function. That's because it's not the right name, and therefore you see the error there. Yeah. Yeah, of course, that's add entry. It should be entry add. So that means that I need to correct it. Let's go to our file. Let's open up that, and let's look at the help file. And it should be entry add. So that was a mistake, but then I can run the site again, preview it, and then now it should actually fix up. Oh no, it wouldn't fix it up. I need to do the document first. Yep, and that's because it's important that it's rewriting the matrix ops RD, and then I need to do the building site. Because all it does is that it's actually just reading from your rendered file. So if you haven't done that step, it wouldn't update. So now if I go to reference, click on this, you can see it's updated the examples. So very easy, right? Because it's only just been like 2 commands. But I want to host this. And so traditionally, if you wanted to host it, you had to push this file, and then you have to enable GitHub pages and so forth. So there was a lot of friction beforehand, but again, use this package has been updated. So there is now like a GitHub page action, a package down action. So you go here, and if you have everything set up, so linked up with your Git and GitHub, and what happens is that this will actually link it up and create all the necessary files. And it will also make the GitHub pages enabled in there. So now when it's also giving me the URL here directly. So that's very handy. I don't know if it will be ready. It takes a little bit of time. Yeah. So it takes a little time because it actually needs to render it on GitHub pages side. But if you give it a few more minutes, and we'll come back to it, this should actually just show the local version of what we have here from a public URL. Now, this link usually you want to put this in the metadata, right? So now if you actually go to the description file, magically it has added for you what the particular link is, which is super, super handy, because that's one of the things that you have to remember to do, right? When you create one, you have to remember to also add it to the metadata itself. So you need to come back to description and add it. Notice here that also, because now it's hosted on the GitHub, and it's a public one, it's also created like a bug report location as well. So this is where you can put in like reports of the any bugs for people who are using it publicly, and it does this automatically, everything for you. So if you forget something, well, you have to make sure you do it. But use this actually is very considerate. It like every little thing that you do, if it's such a common thing, it's already built in so that those things are done for you. Now, of course, the downside is that I think because if you do use this modern approach, you actually, I guess, lose the experience from actually having to, do all the work. So sometimes I think now people have lost the ability to actually understand the actual how our package structure works, because things have become so convenient. And so, that's a bit of a downside of the convenience. But once, like for your everyday use, this has just been so great for having a frictionless workflow. A question? What was the command for initializing the repo? So that's the use GitHub function. Is the Python versus R still a debate? And yes, but like I think just use whatever suits you. And certainly if you're doing a lot of stats, R is quite useful, I have to say. A lot of machine learning, I would say Python is very useful. Okay. So this really kind of gives you the big picture of like all the development workflow. So I showed you already, the available function, create package, a function from use this, use Git, use GitHub, use R. I haven't shown you the data one. I load all. This is generally speaking, use a shortcut to enable it. And then there's some other ones which are to do with the importing of the package. For example, here, what happens is that I may want to actually use a particular existing package. Maybe I want to use dplyr, use package. And then so dplyr is something that I want to use within the functions. And so by doing this, what it does, and again, it's just to do things like make the workflow like frictionless. All it does is that it actually just adds extra line onto the imports. So if you have a look at this line here, as I run this command, you can just see that it just adds that. And that's all it does, actually. But then, you don't have to remember exactly where that location is. Now, by having this under the imports, what happens is that then you can start to like refer to it. For example, maybe here, I'll do import from dplyr, and then I want to use the, what do I want to use? I will use add row in the, or is that tibble? Yeah, add row is dplyr, good. So I can use that. By putting this, what happens is that I can start now using the add row in here. So this is going to be a bit silly. I can do like add row. And then here I'll do, what happens if you, what was the name? I think it's V1. Yeah, V1, V2. So I'm going to do V1 equals to 2, V2 equals to 3. So if I do something silly like that, and obviously this is just to demonstrate, normally what happens is that you have to use the double colon to refer to any functions that are outside of the package itself. But then if you find this is tedious because you have to always colon that and it makes the internal code quite messy, you can drop this provided that you put this in the tag itself. And so then, so if I don't have that, it'll produce an error. Documentation. And then, so if I try to do entry add, and then let's use the test. Not the best practice, but anyway. And now if I try to do this, see how it says it couldn't find the function add row. So now if I go back, and so if I do this, we will know to look there. Let's see how it works now. But of course, if you want to drop it, put it in the import. Dplyr add row. Now, if you do that, because it's our oxygen tag, you have to do the documentation first. So document, load, and then now it works again. If I drop that, it will not work. So what was RD name for? RD name is saying that this particular documentation belongs to this one. So this is created as like a shell. And because partly this one contains all the documentation for matrix operations. So I want to kind of put this as in the same family of documentation. And so I've got the name here, matrix ops. RD name says that I'm going to refer to that particular RD. So I'm going to delete that because obviously that's a wrong one. If I leave it like that. There's also this particular function, which is kind of handy if you want to have like a package overall documentation. So if you go and then calling the matrix ops package, what happens is that there's no documentation, so nothing launches. So you might want to have a package kind of overall description. So you can do use package doc. And then what it does is that it creates an additional R file. And then in there, what happens is that it just has basically this simple like R oxygen tag. Here you can start adding like particular descriptions. So this is my R package demo. And then so when I run it, document, load, and then when I look at the matrix ops, do I need to load? Oh, maybe I don't remember. I need to build. I think it's not loading the right one for some reason. Okay, there you go. Now it's showing. I wonder if why, but somehow it needed the build function. But you can see here that it's created this particular help file. And this one has some meta information from your description file. And you can actually add more stuff here if you wanted to as well. This is also vignettes. Vignettes are long form documentation. And then we've seen this. Build and install are just handy ways of actually just doing build and install by function. But of course, you can also do build and install from the build tab itself. You can use check just to see if it passes a simple check within DevTools. That's when, particularly once you're ready to start submitting it to CRAN, these are things that you probably want to do. Now, I did cover most of them. I want to make sure that I answer your questions. So if you have any questions, do put it in the chat.
Yes, please don't hesitate. So that was amazing. Yeah, I have learned a lot from you today, and yeah, I really like the outline. That was very well structured. I hope that you all had enjoyed it as I did. Thank you so much, Amy. Yeah, that was so wonderful. Thank you
Well,
for sharing the link. Yeah.
yeah.
And I will republish that so you do have the latest one.
Perfect.
Do we have a push to CRAN in the next session? I don't know what the CRAN team will think about if it's a demo link.
Yeah.
Maybe when there's like actually a real case example, it might be handy to show for a real one.
Because you have, yeah, I can see one question in the QA session. So, do you have a push to CRAN in next? Ah, yeah, you have already answered. Sorry. Yes, I agree, Pierre, with you. Thank you, Ovi. Thank you for joining us. I think you are done with questions. Yeah, you have you have one question. If possible, you do have some tips in your lecture in GitHub. Thanks so much.
In GitHub, as in the I have provided a link for this one, and basically this actually has all the functions that I used.
Yes, perfectly. I think you are done. Tips about. Okay.
GitHub session, that will be another session, I have to say.
Yeah. So he's asking about tips about the push to push the package to rcran.
With rcran, so there are a lot of like functions which you can check to see passes. So it's a little bit long to run, so I won't do it. So check is one of them. There's other ones as well, which I don't remember. But one of the handy things to know is if you do like a CRAN release, so what was it? Issue release. So there's a use release issue. Now this is quite handy if you're ready to actually release it onto CRAN, because what it will do is first of all it says, okay, what version? I'm gonna release the patch version. This just does a setting of the version. And then what happens is that it'll create this issue automatically for you. And here, what happens is that you go through all the lists So have you done this? And like, check this, everything works. And then these are the commands that you need to do to check that it passes. Once these pass, then you can actually submit it to CRAN. And then again, you can use the dev tools. This will, launch it and then ask you to confirm whether you want to submit it to CRAN. You'll get an email and just need to approve that email and just wait for CRAN to actually approve it or not. I should just show it at the website. Oh, it doesn't work still. It is built. So I'm not sure why it's not released. Maybe it just takes a little bit more time. Pages. Yeah, it says it's live there. I wonder if it's my cookies. Not sure what's happened there. Oh, yeah, there's nothing there. So there's something that's gone wrong. It didn't render it. So basically that needs fixing. So that requires me to dig in and find out what happened. I'll have a look. But if you have any questions, just feel free to write it out as I look into that.
You have a question from Pierre. What's the advantage to have it in CRAN or not, the package?
The CRAN basically, I have to say now it's actually a lot less than before because now you have it on GitHub. What happens is that you can still easily install it. In the past, what happens is that it was a repository whereby if you don't have it in there, people can't easily install it. So it's not as necessary as in the past. But the advantage is that there is like actually some minimal standard that's required to be on CRAN. So that's where all the checks are needed to make sure it actually is set in that standard. And it's actually not a very strict standard, but it's still a level of minimum standard. Once it's been accepted, so you can kind of at least believe that there is some level of trust in the package, that the author actually went to the effort to do all those checks. So I think it's more that it just signals that there's a bit more seriousness behind the package if they're willing to do that.
Yes, yeah, absolutely.
I think Mona's right. It also helps with visibility because you can find it on the CRAN that way.
Yes. So thank you all for your interest in our meetup. Hope to see you later in our upcoming meetups. Yeah, you can plan to have a session about book down or black down. This is interesting topic. Yes, you can do this. I'll just add this to my list. Okay, I don't know, Iwati, if you want to add something for closing.
Yeah, so thank you, everyone. Thank you, Emmy. Thank you, Muna. It was a very enlightening session. And yeah, thanks. And I've looked at all of your recommendations on topics that would happen in subsequent meetups. We're gonna sit down and look through all of that. So before we go, I would like to say a huge shout out again to our sponsors. Common Room. Common Room is a leading intelligent community growth platform that offers more than 25 native integrations It could be integrated with Slack, Discord, and Discourse, Twitter, LinkedIn, YouTube, GitHub, you name it. So it's very intelligent in its nature. Another sponsors that we have today is Beauty Odyssey. They actually help you shop globally and deliver to you wherever you are. So if you're looking for somewhere to shop for your overall beauty stuff from all over the world, you'll find it there. And our third sponsor for today is Microsoft Teams. Later, I'm going to be sharing a link with anyone that is interested that would like to know how to use Microsoft Teams to communicate real time with their community. Because, I mean, when you have a community, you have to keep things going. After this general meetup, people can have questions and all of that. So, Microsoft Teams is actually a great way of achieving that. So, with that, I'd like to say thank you, everyone, for joining today. Yeah, so for networking after this, anyone that wants to network is welcome to wait. You turn the cameras on and you can talk and just meet different people from different all over the world. Some of us are from the US, Lagos, Paris, Melbourne, Italy, like different kinds of different countries, different cities. So if you like to meet people, you're welcome to wait for the networking section. And if you have any question, just respond to the email you got, to lead you to the event, and we're going to answer all of your questions. Thanks.
Thank you, Amy. Thank you, everyone. Yeah. Goodbye. Thank you.